Hello and welcome to the Sound on Sound recording and mixing podcast channel. I am Eddie Bazil. The subject of filters is a huge one, and one that cannot be truthfully covered in a single podcast. So I'll concentrate on sharing some creative ways that I use filters both in terms of sound design and production. I think it's fair to say that filters feature prominently in most areas of our industry, and invariably they fall into two categories: corrective and creative. This podcast will concentrate on the creative aspect of using filters, although there will be the odd corrective process thrown in for the sake of completeness. But before we get funky with filters, let us take a stroll down memory lane and explore how the first electrical filter came to be used in relation to audio. Think transmission, and in particular, acoustic telegraphy. In 1870 or thereabouts, some clever bods sat down with high-grade caffeine and pondered how to improve transmission lines. The plan was to improve the efficiency of first-generation telegraph systems by sending multiple Morse code messages simultaneously, with each using a different frequency tone. At the receiving end, specially tuned filters ensured each recipient heard only one selected transmitter pitch. Once it was established that telegraph lines were able to carry wideband audio, it was a small step, yet a critical one, in creating a system that could carry voice messages. And with the development of suitable microphone transmitters and earpieces, the first telephone system was born. The thing about clever bods is that they never rest, and it wasn't long, circa 1900s, before we were gifted electronic gain. And this came about via the invention of the thermionic valve. This wonder could make up for the inherent losses of passive EQ, allowing EQ boost as well as cut for the very first time. The rest, as they say, is history. Filters have come a long way since the early days of passive systems, and the filters we have on offer nowadays are incredibly versatile, both in application and variety. Let's now look at filters from a creative and character-defining perspective. It is true to state that all marquee brands of synthesizers were defined by their bespoke filter designs and clever integration of off-the-shelf components. Yes, the oscillators, the circuit path, the components, the modulation matrix, and so on went a long way in defining a brand's sound, but it was and is the filters that tended to grab all the attention. Some notable examples being the 900 series Moog filters with the famous 904B transistor ladder filter design, the ARP 4012, a copy of the famous Moog ladder filter that led to litigation from Moog, which resulted in ARP creating the 4072 filter, the ARP 2500-1047 multimode filter, and one of the first of the multimode filters, Roland Jupiter 8 OTA filter using Roland's own IR3109 chip filter, the Korg 35 IC Salon key filter that gave the distinct cutting MS-20 sound, the famous EMS VCS 3 diode filter, which does things that no filter should, the Prophet 5 SSM 2040 and CEM 3320 filters, Oberheim SEM, which should be renamed as the God filter, PPG Wave 2044 filter, Matrix 12 CEM 3372 trouser flapping filter, the squelch of the TB303 diode ladder filter. The list is endless. But it didn't end with synthesizer filters. Nope, some companies saw a gap in the market and exploited it with glee. Filter boxes or filter banks began to appear as not only a cost-effective way of owning and manipulating various filters, but as sound design tools in their own right. Q PV Spectrum Analog Filter Bank, which is gorgeous on pad sounds. Mutronics' Utterly Mad Mutator for just about every filter application, and it came as stereo. And for those who like their eyes to bleed, the Sherman Filter Bank, one of my all-time favorites. These were but a few filter banks that graced our studios. Let's move on now with the audio examples. In example 1, I'm using Cherry Audio's Voltage Modular, my favorite new modular VSTI, to show how a triangle waveform can be filtered into a sine waveform. First, the sine waveform, and the triangle waveform. And now, the filtered triangle waveform to a sine. Voltage Modular is a powerful and well-specified modular VSTI plugin. It is surprisingly easy to use, and creating complex and evocative sounds on the fly is intuitively fun and incredibly simple, thanks to the huge library of modular components available. This example is more of a sound design exercise, and is a great way to show how a filter can be used to alter a harmonically rich waveform, in this instance a triangle waveform, although a square waveform will also work, into a non-harmonic pure waveform, i.e. a sine waveform. Within Voltage Modular, I've created a single instance of a triangular oscillator and shaped it with an envelope generator. This is then routed to an amplifier, which is then routed to a simple 3-mode filter, which in turn is routed to the main outputs. This gives me a simple basic triangle patch to work with. By applying a low-pass filter to the triangle sound, I'm able to filter harmonics and replicate a sine waveform. In the second example, I'm going to create a sine tone preset using only a filter with no oscillators getting involved whatsoever. This can be achieved if an analog self-oscillating filter is used. Digital filters do not generally oscillate but can be designed to do so. I'm using Cherry Audio's Memory Mode Synth VSTI. Here is the processed example. The first step is to disable all the oscillators and modulation routings. Next, you need to tighten the filter's bandwidth until it starts to self-oscillate. Tuning to the desired frequency is achieved by adjusting the filter cutoff. Finally, make sure to switch on filter tracking, as this will allow the keyboard to track the filter's pseudo-frequency. And don't forget to shape the response using the filter envelope. I have used delay and reverb effects to further add some character to the state tone. The result is an ambient sine tone that lends itself to syncopated rhythms and searing lead lines. Example 3 demonstrates how a simple, boring sine sub-bass sequence can be shaped into a swelling, throbbing, moving bass using the magic that is FabFilter's Volcano 3. Here is the dry, unprocessed version. And now the processed version. FabFilter's Volcano 3 is an update on an already powerful plugin. Volcano is a filter plugin on steroids, and what makes it so special, apart from the fact that the filters are analog and can be made to self-oscillate, is that it has a simple yet powerful modulation matrix, which goes a long way in crafting new motion-based filter effects. Sine sub-basses can sound great when used to underpin a beat or to fill out the low end of a mix, but on their own, there are limitations as to what processes can be used to color the sound, thanks to the fact that they don't contain harmonics. This is where sound designers and producers get creative. Distortion is the usual port of call when it comes to forcing sine waves to generate harmonics, but there are other options out there that can make an uninteresting sine bass more interesting. Enter FabFilter's Volcano 3, a weapon that can both control a sound and warp it to oblivion. How you approach the structuring of filter types and styles is up to you, and everyone has their own particular workflow. But I tend to start with a single bell filter and place it at the fundamental of the sub-bass, which is quite easy when dealing with sine waves, and boost this until it self-oscillates. I then flip through the various filter styles until I ballpark the color I'm after. This helps me in deciding whether a distorted or clean and controlled effect is what I want. I then create another filter node, band, at an octave above the fundamental and go through the same steps as previously. I top this structure off with a high-pass filter just below the fundamental. I do this because I know that once I modulate the two filter bands, they will invariably scan below and above the fundamental, and that will determine how much of the very low frequencies I want creeping into the overall sound. With this particular example, I've selected two bell filters and opted for raw styles. I've placed a high-pass filter at around 17 to 20 Hz. Modulation of filter bands is provided by two sine-shaped LFOs. LFO1 modulates both the filter frequency and pan of filter band 1, which is a bell placed at around 36 Hz. The LFO shape is a sine, and I've synced it to the host tempo at quarter bar divisions. I've set glide to maximum to afford a smooth sine shape response. LFO2, again sine shape, modulates filter frequency of band 3, which is placed at 72 Hz. The LFO is running at half-bar cycles, and glide is set again to maximum. Filter band 2 is a high-pass filter with a 48 dB slope or gradient, and is used to clean both the overall response and to allow certain frequencies to poke through into the overall sound. Adjust this to taste. The two bell filters are modulated at different values, and this is what accounts for the nice interchange of frequencies from band to band. In effect, both LFOs scan the frequency ranges of both bands, with each filter crossing over into the other filter's territory. This results in a summing effect at the peaks of both filters, which comes across as self-oscillating distortion. Finally, I've used the mix function to blend the wet signal with the dry input signal. This parallel feature helps to control and emphasize the overall color. The result is a throbbing, distorted bass which moves ever so delicately across the stereo field, thus affording motion to a staid and static bass sound. In the next example, I'm going to use Rob Papen's XY transfer plugin to add some exciting movement to a run-of-the-mill drum beat. First, the dry, unprocessed version. And now, two processed versions. The second processed example is there to highlight the throbbing effect and to show how easy it is to create a bass texture using a drum beat and a very clever processor. XY Transfer is another incredibly intuitive and creative plugin made by Rob Papen, and I can honestly say that you will never tire of the limitless possibilities this processor offers. There are simply too many parameters to list here, so the screen grabs will hopefully help you to get into the ballpark. However, I will outline the basic and most important parameter edits to help get you started. I've used the shaper mode to modulate 83 Hz of the drum beat using the sine wave shape as the modulator, and I've synced this to the BPM of the drum beat within the DAW and selected a nice, gentle, one-to-one sync value. The idea is to squelch the sound before it is passed into the comb filter. The comb filter is where all the action takes place, and I've opted for comb positive as the mode and honed in on a frequency of 640 Hz. I've selected a feed value of 50% for the mode, but the real action takes place at the X and Y axes as the modulator will move using these two extremes. And it pays to experiment with the various parameter settings until you achieve the desired texture. I've synced the modulator to the beat's BPM, but you really need to use your ears to gauge how the sound moves in time with the BPM of the beat or the track. Using the sync mode and selecting the right subdivision always helps, but because I'm using a sine wave shape to modulate both the X and Y axes, and I'm using this particular shape to scan both forward and backwards, it helps to nail the exact flow of the modulator scan. I've made sure to emphasize the dips in the shape so as to give a heavy throbbing texture. I've set the sync subdivision to a half. That scans and modulates at half the speed of the shaper, and this, along with the dips and rises of the sine wave, is what gives a swelling throbbing effect. At the output, I've used a very gentle delay effect to accent the ghost effect of the swells and dips. The result is an evil swelling of dirty frequencies. I am joyous. In the following example, I'm going to take a drum beat and make the different drum elements sing using two resonant filters in series. Here is the dry version. And here are the processed versions. I've added a bass line in the second example just to highlight the ambient texture of the beat and bass combined. I am using two processors in series. The first one is Soundtoys Filter Freak 2 Filter Bank, which is then fed into Soundtoys Echo Boy delay plugin, which adds some gorgeous delay reverb depth and makes the whole sequence all gooey and ambient. In Filter Freak 2, I'm using two resonant filters in parallel. The first filter is a bandpass filter working at around 200 Hz and with resonance set to gently self-oscillate. This allows for the peaks to ring and hang in the air. The second filter is also a bandpass filter and working around 2 kHz. Resonance is set to just touch self-oscillation. I'm using a random sample and hold modulator synced to the beat's BPM at 16th subdivisions. I've set the modulation depth to allow each filter to cross-modulate between the two cutoff limits. This gives that nice cross-motion across the two filters. Filter Freak is then fed into Soundtoys Echo Boy for some ambient magic. I'm using the rhythmic echo mode and the delay is set to time with a value of 47 milliseconds. I'm using 16 repeats, but I've used the fade function to reshape the response. I've used heavy saturation at the output stage and ran this through the ambient output mode. The result is a nice poppy type of delay effect that sounds more like a deep repeated reverb than a simple delay. The two processes need to be shaped together, as a small change in one will heavily affect the other. And my suggestion is to start with the filtering and use the delay to further color the filtered sound. The overall result demonstrates how easy it is to dramatically alter a boring drum beat into a vibrant ambient sequence using two simple yet powerful processors. For the final example, I'm going to concentrate on structuring a short piece of music using Formant filters creatively to reshape a run-of-the-mill washy pad sound into a more interesting texture, which hopefully, once put together with other sounds, will sound coherent and passable as a piece of tolerable music. Have a listen to the dry, unprocessed version. And now the processed version. I'm using AudioThing's The Orb, a wonderfully simple yet powerful Formant filter bank. I've covered Formant filters in the Vocoder podcast, so if you fancy a brush up on the subject, head on over to Sound on Sound and check the podcast out for yourself. But in a lazy nutshell, Formant filters simulate the characteristics of the human voice and concentrate in particular on creating and shaping vowels. To list all the detailed features of this plugin would take some time, so I recommend you trial the plugin and read the manual which describes all its features nice and simply. You'll have great fun experimenting with this processor. I decided to shape the pad sound to behave like a voice, but without emphasis on any particular vowel. In fact, I've selected a large palette of vowels and programmed the plugin to scan and modulate each vowel. I've made sure to allow for morphing between the vowels as opposed to highlighting specific vowels in isolation. This gives that lovely phasey washy effect you hear when the pad switches between chords and notes. AudioThing have given us the most important parameters to play with, notably altering the phase of the modulators, which allows for all manner of modulated responses, drift and smoothing, which can be extremely expressive in managing the transition from one vowel to another and the overall behavior of the orb, and detailed editing of vowels, both in placement and frequency ranges. I started by selecting female as the overall mode for the orb. I set the drift range at around 200 Hz and made sure the drift polarity was set to plus. Play around with the polarity once you have the Formant filter shaped and ready. This will help you in determining which polarity to select. Let your ears do the work here. I soloed each modulator and shaped it to taste. For the vowel modulator, I set it to clockwise, so the modulator would cycle in a clockwise direction. I set rate to a half and amount to just below halfway. I left phase at 1. I selected a sine wave shape for the emphasis modulator and set the phase to 360 degrees. I chose the rate to be 1 bar with a hefty amount. The drift modulator mimics the vowel modulator, but using a sine wave shape for the modulator itself. The result is a gorgeous journey of morphed Formant filters bouncing along, giving the pad sound a seductive motion. Gauge the overall effect by counting your bodily goose pimples. But it doesn't end there. I've also dragged the percussive line into the project and added motion using the Waves Meta Filter plugin. Have a listen to the dry version. And now the processed version. MetaFilter is a simple and effective filter plugin, and it has a couple of very useful features, like a step sequencer that can be used as a modulator, and a good combination of LFO and envelope-driven source modulators. For this example, I've programmed MetaFilter to modulate the filter resonance of a low-pass filter using the step sequencer. I've also used the sine-shaped LFO to very gently modulate the filter cutoff. And because I'm using it in parallel, the movement of the cutoff and resonance played against the dry sound comes across as modulated pans. Very cool effect. The end result is a percussive line that has acres of motion and character. Let me end by adding all the parts, highlighting the orb pad wash, and hopefully it will all sound nice and squidgy. Thanks for listening. This has been Eddie Bazil for Sound on Sound.
Thank you for listening, and be sure to check out the show notes page for this episode, where you'll find further information along with web links and details of all the other episodes. Oh, and just before you go, let me point you to the soundonsound.com/podcasts website page, where you can explore what's playing on our other channels.